find the derivative of y is equal to root of x, or the square root of x. So that is just f of x. And we're going to be using the limit, or sorry, the definition of the derivative. So we have the limit as h approaches 0 of f of x plus h. Now, what is f of x plus h? We're just going to plug in the x plus h for x. So we're going to have the square root of x plus h minus f of x, which is just the square root of x, all over just h. So what can we do here? Because we eventually want to get rid of this h down at the bottom. Once we do that, we can just plug the 0 in for h. But how are we going to be able to simplify this? Well, how about we multiply the top and the bottom, or the numerator and the denominator, by the conjugate of the square root of x plus h minus the square root of x. And what is the conjugate again? We're just going to take this binomial and switch the middle signal. So we're going to have, actually I'm going to need more room. I need a lot more room. All over h. Okay, so I'm going to be multiplying this by the square root of x plus h plus the square root of x, all over the same thing, of course. Okay, so what's going to happen here? So we have the limit as h approaches 0. Now, what we can do is that we can expand this. The square root of x plus h times the square root of x plus h is just x plus h. Then we have the square root of x plus h times the square root of x. And that is the square root of x times x plus h. Fantastic. And we continue distributing. Minus root x times the square root of x plus h be minus square root of x times x plus h. And finally, we have minus square root of x times the root of x. This times that is just going to be minus x, all over h times the square root of x plus h plus the square root of x. I won't actually distribute the h over down here, just because I want to eventually simplify things anyways. So just leave it like that. But look at this. Look at this. These are the same. And they're going to cancel out. Isn't that great? Yeah. Wow. Fantastic. That's, of course, that's the reason why we chose the conjugate to be multiplied by the top and the bottom, because we would be able to get rid of the middle term. And look at this. We also have x minus x, also 0. They just cancel out. And of course, just in case, I'll mention this. Why did these cancel out? Because it was just plus, right? So positive square root of x times x plus h minus square root of x times x plus h. So they just canceled out. So we're only left with an h up top. So we're almost there. So we have the limit as h approaches 0 of h, all over. Just make a nice straight line here. H times the square root of x plus h plus the square root of x. Now the h's cancel out. And we're left with 1 up top. And we can finally plug 0 in for h. Fantastic. So we're going to have 1 over square root of x plus 0 plus the square root of x. The square root of x plus 0 is just square root of x. The square root of x plus square root of x is just 2 square root of x. So this is our final answer. And that is y prime, the derivative of the square root of x. Here we go. One more rectangle around the answer, and we're done. That's it.